Hey everyone, this is Chris Gonzalez, and it is week 7 of micro bio at LAPU. That's bio 225. So really excited. This is the last lab for the semester. Week 7 actually allows us to end it a little bit early, as next week is just a kind of a easy wrap up. This week's lab video is going to be on the Kirby Bauer diffusion test. So I was looking over the overview for what we have to do in this video presentation. It kind of just is like an open discussion on what the Kirby Bauer diffusion test is, and then what some other items are. So let's just jump right into it. So first we're going to describe antibiotics versus antimicrobial agents. So antibiotics are actually natural substances that are produced by microbes, my apologies. That aid in pretty much preventing bacterial growth, right? Antimicrobial agents, on the other hand, are synthetically made in a lab. So those are kind of your ways of creating effective antibiotics, let's just say. So when we think of antibiotics versus antimicrobial agents, although there's some crossover, you got to remember that the true things that we are making medicine-wise are antimicrobial agents, right? So there were three sort of antibiotics we're looking at in this lab exercise. It's going to be penicillin, that's going to be novobiocin, and gentamicin. All right, so let's just kind of give a brief overview. So penicillin, as you all know, is a super famous. It's pretty much what's called a bactericidal antibiotic. So pretty much it's going to involve lysis and death of the bacteria. So penicillin will normally be a narrow spectrum drug that is going to essentially target, call it gram-positive bacteria, right? And the way it does this is it just prevents or disrupts formation of bacterial cell. So going on to now the opposite end of that, let's go to novobiocin. So novobiocin is a bacteriostatic, which doesn't effectively kill the bacteria. It just means that it prevents it from continuing on in growth, right? So think of it that way. It's not killing the bacteria like it would penicillin, but it prevents it from kind of expanding, right? And the way it does that, it's going to target this thing called DNA grace, which is some gram-positive bacteria. And DNA grace is pretty much just an enzyme that allows for replication of DNA. So going on, last one is gentamicin. So gentamicin is pretty much another bacteriostatic, and that's going to target pretty much aerobic gram-negative bacteria. So it essentially will bind with ribosomes and other cellular structures and prevent protein synthesis. So again, it's not killing the bacterial cell, it is eventually just preventing it from growing, right? So the cool thing about this Kirby Bauer test, pretty much all labs across US now do it at some form or fashion. It's pretty much just checking regions using little agar discs. Pretty much what we have to do is zone it off into 3 separate sections, putting all 3 of our bacteria, my apologies, in connection with the 3 antibiotics. So pretty much what we're going to do is be measuring the zones of inhibition. That's not saying that the bacteria is necessarily getting attacked by the antibiotic we're exposing it to, but we're just trying to categorize whether something is resistant, susceptible, or intermediate to the antimicrobial agents that we are exposing it to. That essentially means that even though there may be a very large inhibition zone, it doesn't necessarily mean that that drug is specifically working greater than the other drugs with that bacteria, right? So our bacteria in this case is S. epidermidis. So we'll essentially be putting that in our agar, and then we'll be exposing through these little cubes. the 3 different antimicrobial agents, right? So then we're going to pretty much incubate it, take it on a sort of examination, and then see what we end up getting. Other than that, thanks guys, it's been a great semester. Hope you've all had fun. I've had a bunch of fun, and here's to the next one. Have a good one, guys. Bye.